which my grandma used to say that's considered a lie too. So the fundamental theorem of calculus has two parts. Part 1, which I did not discuss, and part 2, which I did. So there are two parts. Let me rephrase this one again. So the integral from a to b from f of x dx equals the uppercase, which is the antiderivative from a to b, as we know, f of b minus f of a. We use this over and over. Okay, now what about this part 1? What is this all about? So as you see, part 2 teaches us how to determine a definite integral. Of course, for a continuous function on a comma b. This is an absolute condition, mandatory condition. Otherwise, fundamental theorem of calculus part 2 is not applicable. But what is this part 1 all about? Part 1 teaches us something else. It teaches us that differentiation and integration are inverse operations. And how does it do that? So here is the idea, and we'll explain how this works, and then we'll apply it in problems. So part 1 teaches us that differentiation and integration are inverse operations. First of all, what does that mean? If I integrate a derivative, I get the function. If I differentiate an integral, I get the function. Like, for example, e to the x and natural log x. These are inverse operations. If I apply the exponential to log, I get x. If I apply log to the exponential, I get x. If I integrate a derivative, I get the function. If I differentiate an integral, I get the function. So this operation cancels the differentiation. This operation cancels the integration. That's the part 1. How we illustrate this? Okay, we understand, but let's see how does this look. Okay, so let's take a look at our best friend, our function.
The camera went out.
Of course, because I touched this cable with my paper. Thank you. I know it cut it again, so I'm just moving that cable away. Well, let me see now. Okay, I moved it out of the way, so maybe that's not going to happen again. Okay, so we have a function f of t.
Camera's out. Sorry.
No, thank you. So we have a function f of t. So this is t, and this is f of t. And you can say, wait a minute, you always use x. All of a sudden you're using t. Why is that? Bear with me. It's a very good question. Even if you didn't ask it, I did. Okay. This is really annoying that this happens, and this time I haven't touched anything. Let's see if this one works. Maybe. Keeping my fingers crossed. Okay. So this is an interval, of course, our best friend, a comma b. Is this function continuous on a comma b? And I'm sure you're going to say yes. And okay, so I didn't touch anything. As I said, it has a mind of its own. So this is the area under the graph. So of course we know this already, that this is the area and this is the integral from a to b from f of x dx. Of course, f of t dt. That's what we have now. Okay, so now let's say that I have x, and x is a number between a and b.
Down.
Yeah, okay, let me